You can do a uniform distribution if I put one on the quiz tomorrow. It would probably be just very similar to this, drawing the picture and answering a couple of basic probabilities. Uniform, it creates a rectangle, so probability is just 1 times width. Number 5, we have that Z alpha question. So there will probably be one of these on your test, and I'm really just wanting to see if you understand what that means. So when it says Z alpha, that 0.34 is area to the right. So it's saying 34% of the area is to the right. You have to find the Z value that it corresponds to. So that's your picture, the normal curve with that area to the right shaded. We know though, for whatever reason, the notation doesn't match the way the table's set up, just the way it is. The table gives us area to the left. So 34% is to the right. How much is to the left? So my area is 66. So I'm looking inside the normal table. So everyone pull out your formula sheet. You are trying to find as close as you can get to 66%.
On the Z?
Yes. And so that looks like it's 0.41 because you get 0.6591. So that is our Z. 0.41. Now I'm full. I thought I wanted the fresh air. It's too much. All right. Anything else on that front page? That's all good.
Whenever on like 3B, whenever it says 2 interpretations of it,
Uh-huh.
how do you, I got one of them, but I was kind of confused on like what to do for 2 of them.
So basically, one of it, you could think of it as a probability. So in this case, you could say the probability that, what were we even looking at?
Miles per gallon.
So the probability that a motorcycle gets between whatever, 24.5 and 29.3 or whatever it was. Yeah, I was looking at part 8 for a second. So the probability that you get between 23.7 and 29.3 miles per gallon is 0.6419. So the probability of one given motorcycle. The other way to think of it is out of the population. So the proportion out of all the motorcycles I looked at, it's a proportion that had the miles per gallon between those two numbers. So think of it as a probability of one or the proportion of all of them. All right, number 6. It tells us that the average is 20.8, so that's your mean. Your standard deviation, so that's your sigma, is 4.6. And we know it's normal. So we asked about B. We want the probability that our score is between 20 and 26. Okay, but that's our X. So what do we have to do with those?
And Z score?
Mm-hmm. So Z is our value minus the mean divided by standard deviation. So Z's we have to round to 2 decimal places for the purposes of looking them up on the table. So that one's negative 0.17. This one, our value, 26, minus 20.8 divided by 4.6 gives us 1.13. So we are finding the probability that Z is between these. All right, so between is when we subtract the probabilities. You have to look up the bigger one first. So we go to our table. If our Z is 1.13, that 8708. If our Z is negative 0.17, that is, I lost it. Okay, and And so then if we subtract those, we get our probability.
So you don't have to do like the 1 minus if it's to the right still on this?
You don't, so what happens is, there's different ways you could get it. This is just the most concise. If you're between these two, if you look up the bigger one, it finds all of those. So then if you subtract off the smaller z, it subtracts off that end and just
Yeah,
leaves you between.
that's what I did.
You just
Well, I
did
put-
1 minus each.
I did the 1 minus and then I subtracted it. So,
Uh-huh.
yeah.
Other questions on that, or do we need to look at A or C? Number 7 tells us our mean is 39.67, standard deviation 4.38. So we're looking at B, the probability of being between 42 and 48. So first we have to get both of them to be z's. So we know it's normal, so it's just our value minus the mean divided by standard deviation. So that gives me a z of 0.53. Second one, 48 minus 39.67 over 4.38. So childish, as my
She's
8th
staring
grader
at me, I can't.
would say.
You were asleep, Abram. You were like, you started dying laughing.
Dude, no, the first time you said it, she just stared at me for like 15 seconds.
No, I didn't.
You hit me with the, and just stared at me while she
Oh
was,
my god.
said 6-7.
Have to do that if you're asleep.
All right, make sure
No, 'cause I
you're
can feel
following
your
along on your
two eyeballs
table.
staring into my soul.
So if we look up 1.9, we get a probability of 0.9713. If we look up 0.53, so we subtract those and we get 0.269. Right. Anything else on that page that you want to talk about? All right, so this first page, front and back, is really all of the chapter 7 stuff. Okay, basic, what the normal distribution, converting our x's into z's, and getting our probabilities from the table. So that will be a chunk of your test, a bulk of it. Then from there we have two different things. We talked about proportions and sample means. So if we look at problem 9, we know our sample is 36, mean 64, standard deviation 18. I'm going to go ahead and go through at least part A on this. If I say describe the sampling distribution, you have to know your criteria. I'm wanting the sampling distribution of x bar. With x bar, your criteria has to be either be that the population is normal or n's greater than 30. Which one do we have here? N's greater than 30, which means it's enough to say it's approximately normal. Okay, that is, the criteria is the thing that's not on your formula sheet. Everything else is. So then we need the mean for x bar, and standard deviation for x bar. So straight off your formula sheet, the mean for x bar is just your sample mean, which is 64. Standard deviation for x bar is sample standard deviation divided by the square root of n. So 18 over the square root of 36, and we get 3. So that's what part A was looking for. Once you have that, the rest of it is like what we were doing on the front page. You just use this mean and standard deviation to calculate any z-scores. So for part D, we want the probability that our sample mean is between 59.8 and 65.9. So we convert each of those into z's. So our value minus the mean divided by standard deviation we get a negative 1.4. This one, 65.9 minus 64 over 3. So we would get 0.63. So we need the probability that z is between them. So again, we look up on the table. So we go to normal table. When our z is 0.63, the probability is minus, when we look up negative 1.4. And if we subtract those, we get 0.61. All right. Is that one okay? 10. All right, so I'm going to go ahead and do A as well on this. It asks me, or it tells me 22.4%. So anytime you see a percent, that's your proportion, your p hat, 0.224. Sample of 300, so n is 300. So part A, describe sampling distribution for p hat. So you have to know your criteria. What criteria do we use for this one?
N times P times 1 minus.
Has to be greater than 10. So 300 minus 0.224, 1 minus 0.224, 52.1472. So that's good. We should also verify that it's less than 5% of the population, but if we're talking about 300 adults, would that be less than 5% of the total adult population? Yeah. Okay, then everything else is on the formula sheet. So our mean for p hat is what? Right? And then our standard deviation, what do we do?
Square root of p times p 1 minus p divided by n.
From the formula sheet, and we get 0.024. You can keep more decimal places if you want. It would round up to 1 after that. So then part B says, what's the probability of obtaining 141 or more? If you're using that, you need p hat. P hat is x over n. So 141 over 300, that's where the 0.705 came in. Okay, I was just telling you what that was.
John's question.
What question you on?
Oh, I jumped down to number 11, didn't I? Sorry, let's go back to problem 10. You don't want to do a combination of them?
No.
Okay,
I had trouble enough with this.
the probability that at least 50. So you need p hat x over n, so 50 out of 300 is
Sorry. Hey, all right, everybody just stares at me.
so we want at least 50. So the probability of being greater than. So what do we do? Our value minus the mean that we had in part A divided by our new standard deviation. Okay, so we get, oh, I wrote my, and we get all right. So the probability of being greater than that, greater than is 1 minus. Then we look up negative 2.38 on our table. is 0.9913. Do we need to look at C? You just have to find probability of 0.18 being less than that. And what does it take to be unusual?
5%.
Under 5%. All right, now let's go to 11. So I'm going to go ahead and talk about A as well. You have to have that to do the others. We know our sample size is 200. Population was 32,000. And our P is 0.63. So, describing the sampling distribution, we have to check our criteria. Which N times P times 1 minus P. And so that's comes out to be like 46.62, which is definitely greater than 10. So that's good. Is 200 less than 5% of 32,000? Yeah, so our criteria is good. Then our mean for p hat is just our p, 0.63. Standard deviation for p hat.
Square root of P times 1 minus P over
Okay, and when we do that, we get, so what you really should be picking up on, what's really the only thing you have to memorize?
criteria.
Your criteria. You have to know the criteria for P, hat, and X bar. Everything else is on the formula sheet. And ultimately, all these problems are doing the same. Once we get our mean and standard deviation, they're all just finding the z-score and looking up from the table. Okay? So, when I look at this one, we want, what am I doing here? We were C. So what's the probability of obtaining 121 or fewer? So we need our p hat. So x over n. So that is 0.605. We wanted that or fewer, so that probability that p hat is less than or equal to 0.605. So now what do we do? Z-score. So Z is our value minus the mean divided by standard deviation. So that gives me a Z of negative 0.73. Less than is just from the table, so I go and I look up negative 0.73, and we get, yeah.
So is the only time we have to look in the chart and find the numbers whenever it's like the Z and then like
The Z alpha, yeah.
That's the only time we have to go into the chart and like look for the numbers inside.
Yes. Problem 12, you guys didn't ask about it. Are we good? Confidence intervals, remember you can do them by hand or you can do them on the calculator. Do you guys remember how to do them on the calculator?
That test
Okay.
A.
So there's two different types, whether we're doing the T interval or the Z interval. So it's either stat test number 8 or stat test letter A. On number 12, which one would I be looking at? A. So, and you'll know when you go into it if you pick the right one. So everyone goes stat test A. If you pick the wrong one, it's going to ask you questions we don't know. Do we have an X in this problem?
Yes.
Yes, 80. Do we have an N in this problem? Yes, 200. Do we have a confidence level? Yes, 0.98. So I was able to answer all the questions, and it will calculate my confidence interval for me. Okay, you can also use your formula sheet and just do it by hand. It's not a very complicated calculation, so we should be able to get it either way. Did everyone get that?
We use the other one if there's like a table, like stat test.
You use that when we're talking about the X bar, the
Okay.
sample means, yes. And that one, you can either have a table or the numbers given to you. So, let's see, we didn't ask about 13. Number 14, let's take a look at that. A school administrator wants to estimate the percentage of full-time college students who have credit card debt of $2,000 or more. What sample size should be obtained if she wishes the estimate to be within 2.5 percentage points with 94% confidence? All right, I want you to go to your formula sheet. It said what sample size? So, where do you think you look on your formula sheet? Okay, if you look under chapter 9, that right-hand side, it says sample size, and there's 2 bullets for that. So the first bullet you can see is all about p-hats. The second one is about the population mean. So we have to decide, do we have a proportion or a mean on this problem? Proportion. Okay. Part A tells me the study indicates a percentage is 34%. So if you look under that first bullet on sample size, it gives us 2 formulas. N equals p hat, 1 minus p hat, times z alpha over 2 divided by e squared, where p hat is a prior estimate, or n equals 0.25, z alpha over 2 divided by e squared, when there's no prior estimate available. Do we have a prior estimate here? Yes, that's what that 34% is. So that p hat, my prior estimate, is the 0.34. The other things we need, z alpha over 2. Okay, I tried to pick a percent that you couldn't just look at your table in the bottom corner. I know. So 94% confident. If you are 94% confident, that means 94% is in the middle. How much do we have left over?
3 on each side.
6, so 3 on each side. So, if you are going to look this up, what proportion is to the left? 97. So 3% is to the right, 97% is below. So you're looking inside your table for the 0.97, the closest you can get, which is what?
0.9699.
0.9699, and that corresponds to a z of 1.88.
Where did 0.97 come from?
I added these up because the table gives us everything to the left.
Okay.
Then we have to have our error. And it told us in the problem 2.5 percentage points, so that would be 0.025. So then we have 0.34, 1 minus 0.34, 1.88 over 0.025 squared. So if I plug this in, it gives me 1,268.99. However, what do we have to do at this point?
Round up.
And you round up regardless of what that decimal is, because it tells me 1,268 is not enough. So part B is saying no prior estimate. So that's when we use the second one. We already have all of our variables identified. So we just plug in. So we have 0.25 times 1.88 divided by 0.025 squared. That's not a point. That's, never mind. My handwriting is just sloppy today. And that gives me 1,413.76. So we would have to have 1,414 people.
How do you get that error again?
It was given in the problem. It said it wished to be within 2.5 percentage points.
If it doesn't say it's 1 minus the population, right? Or population minus 1. or something like that.
In minus one.
A minus 1 is degrees of freedom.
Oh.
So on these, I would have to tell you an error.
Okay.
Yeah, Natalie?
On the chart, when you were getting the 1.88, you were going to the highest level without crossing the 90.
You just want to get as close to 97 as you can. Other questions? Let's talk about 15. We only asked about 2 of them. I'll go ahead and look at all 3. So the t-table, we did not use as much. So we definitely don't have as much practice with that one. But we should be able to read that still. So it tells us we are looking for a t-value. So as soon as I see that t-value, I know I'm going to my t-distribution. So everybody flip that one. All right, notice, if you forget, it tells you at the top of the table. It's set up, this table gives us the area to the right. So on A, the area in the right tail is 0.05 with 33 degrees of freedom. So you just go down to 33, over to 0.05, and we get part B. The area to the left is 0.005, 19 degrees of freedom. Here's the thing. This is symmetric around 0. So can I look up, if 0.005 is to the left, that means 0.995 is to the right. Is that on my table? No. So all we have to do is recognize that it'll just be the negative of whatever's on my table. Okay, so then I go to my 19 degrees of freedom, so row 19, over to 0.005. And it's a negative because I want it to the left. C corresponds to a 96% confidence. Okay. That means 96% is in the middle. So how much is left over? Okay, so when I'm looking up area to the right, it's 0.02, 23 degrees of freedom. So down to 23, over to 0.02, and we get to 0.177. Does that make sense to everybody? The only time we use these t-values in our calculation is for the confidence intervals with our x-bars. So we do have a couple more questions. So 16, determine the point estimate for the population, proportion, margin of error, and x. Our confidence interval goes from 0.051 to 0.074. And our n is 1,120. Our p-hat, remember your confidence interval is just centered around that. So it's right here in the middle. So how would I find it? Good. So I'm just averaging those, and we get 0.0625. Your error is shown on here twice. It's how far either direction that you go. So all you have to do is just subtract either your upper and lower bound with your p-hat. So if I do 0.0625 minus 0.051, we get 0.0115. To get my n, you have to use the fact that p-hat is x over n. We know our p-hat. We don't know x, but our n is 1,120. So if you multiply that over, x is 70. Any questions there? Problem 17. survey asking 40 Americans how many books they read per year. Found. So our X bar is 13.4. S was 16.6. And is 40. So find and interpret a 99% confidence interval. So we can do our confidence interval by hand or from the calculator. I don't care which. If we do it by hand, how many degrees of freedom would we have?
39.
39. It's always one less. You would have to look up. We want a 99%. Do you guys, let's practice reading our T table. If you want a 99% confidence interval, 99% is in the middle, so how much is left over?
0.005.
So you would have to look up the 0.005 and the 39 degrees of freedom. So we would get
2.70.
2.70. And so then if you were working it by hand, it tells you on your formula sheet it's X bar plus or minus your T times the square root of S over times S over the square root of N. So you can certainly do it by hand. If you want to do it on your calculator, let's practice. Where do we go? Stat test number 8. Make sure, do I want to base it off data or stats? Stats. Data is when you have your stuff entered in L1, like if I gave you a table of values. If I go to stats, let's check. X bar, I know, is 13.4. S, 16.6. N, 40. Confidence level, 0.99. I know I picked the right test because I have all the stuff it's asking me for. And so then I get the same confidence interval either way. Maybe except for the last decimal. I think your calculator gives you maybe one more decimal place than you get by hand. So the final decimal place might be slightly different. Interpret means what?
That's what it means.
Yeah, tell me what it means. Write a sentence. So we are 99% confident. Okay, this whole thing was about how many books people read per year. So the number of books read per year is between 6.2926